So it's not talking about the instantaneous speed, instantaneous velocity, average velocity that I have already told, because instantaneous speed and velocity, these things can be calculated with the help of differentiation. Suppose here distance is given in terms of time, then we can always differentiate the distance as a function of time with the time to get the instantaneous speed, and in the same way we can differentiate the instantaneous displacement in terms of time with respect to the time to get the instantaneous velocity, and average velocity we have already used, so that's not a point. So here in case of instantaneous calculation, we use what? Differential calculus, the differentiation process, finding the derivative. Alright, so let's take one example for this. The relation 3t is equal to under root 3x plus 6. Here it is given to you that 3t, t is the time, and it is equal to under root 3x plus 6. Alright, so it is given as under root 3x plus 6. Describes the displacement of a particle in one direction, where x is in meters and t is in second. The displacement when velocity is 0 is. So let it put it this way: 3t minus 6 whole square is equal to 3x, taking square on both sides. So 3x becomes here, it is 9t square plus 36, and this is minus what? 2 into 3 into 6 means 36t. So this is the relation. So x becomes 3t square plus 12 minus 12t. Alright. So we have got x displacement basically in terms of time. So displacement in terms of time is 3t square minus 12t plus 12. And we have to find the value of the displacement only when velocity is 0. So first we will have to calculate the velocity using this particular displacement. So velocity we know is the rate of change of displacement. So dx by dt, ddt of t square is 2t. So it becomes 6t. Alright. 2 into 3, 6 into t raised to the power 2 minus 1. So it becomes t. Minus 12 into t, t differentiation is 1. And 12 alone is there, so its differentiation will be 0. So we have to calculate the value of the x when velocity is 0. As we have calculated the velocity, which is 6t minus 12, so for velocity equal to 0, we need what? T is equal to 2. So at t is equal to 2 seconds, velocity of the particle is 0. Alright. So at this instant, what is the displacement? So we can always calculate the value of the x with this given expression. So x is 3t square minus 12t plus 12. So it becomes 3 into t square means 4 minus 12 into 2, right, plus 12. So it becomes 12 minus 24 plus 12. So it is 0. So hence the particle is at the starting position when its velocity is 0 at a particular instant, and the time is t is equal to 2. So in this case, particle must have moved away from the origin at the start and then come back to the origin, the starting position, and for instantaneous rest. Alright, so let's move on to the next question. Here a person travels 10 km north, then 10 km east in equal intervals of 1 hour each. Then the displacement, average speed and average velocity. So it's quite a simple question that you can solve on your own. So let's assume that it is east, west, north and south. So the person travels first towards north by 10 km and time taken is 1 hour. Alright, in equal intervals of 1 hour. And then 10 km east. So it turns to east and then moves 10 km for 1 hour duration. Then the displacement, obviously displacement will be 10 under root 2. So first part answer will be displacement is asked, that is 10 under root 2. What is the average speed? So average speed becomes total distance covered, which is 20, alright, divided by total time, which is 2 hours. So average speed becomes 10 km per hour, alright, and average velocity. So average velocity becomes what? displacement is 10 root 2 divided by the total time. Total time is 2 hours. So average velocity is 5 under root 2 kilometer per hour. So this is the average velocity. So it's pretty simple question. So let's move ahead. A vehicle travels 20 km west and then 5 km north. This is north, east, west, and this is south. So 20 km west, 20 km west particle moves, and then 5 km north, then 5 km it moves towards north. This is 5 km in equal intervals of 1 hour each. This distance is traveled in 1 hour and this also 1 hour. Then the displacement, average speed, average velocity. The same question is repeated with the different values. So for displacement, as we know that we can calculate the shortest distance between the starting and the final point. So displacement delta S is equal to under root of 20 square plus 5 square. So I'm not going to do this. You can solve on your own. Find the displacement, average speed. For average speed, time taken, we know that it is 2 hours. So 20 plus 5, 25 divided by 2 hours. Alright, 12.5 km per hour. And then average velocity. So for average velocity, we'll be using this displacement divided by 2 hours. So that you can solve easily. So this is the end of the first 2 sessions of the kinematics. And this particular session was the starting sessions. So it was just an introduction, and quite simple things were discussed in this session. And in the next session, we'll be covering more aspects of the kinematics. Thank you very much for watching our video.